Good day and welcome again to our mind gym. Remember, when we exercise our brain is when we do math. So let's do some math today to get our exercise in. Now today we're going to work on standard form. Standard form, another word for standard form is scientific notation. So it's scientific notation equals to standard form. Okay, so that is altogether the same thing. Now, let's find out what is scientific notation and where did it come from. When we are speaking to each other and we're speaking about the distance from two houses, the distance between these two houses over here. Okay, so how would we describe the distance of that specific house? We would say it would be meters or kilometers, right? So from this house to that house, we would say it's about 5 meters away from each other. So that's an easy number to work with when we have to work out an equation according to that specific situation. But if we speak about the distance that the sun is from the earth, how far is that specifically? Let's look at that number. So there, with keeping in mind that this is 3 significant figures, which means 3 numbers, 3 actual numbers, not zeros, but actual numbers. Then we have 1, 4, 9, and a lot of zeros. So 149 million kilometers. Now just think, if we had to do an equation with this large number, would we not get tired of writing the zeros all the time? We would, wouldn't we? Now the scientists are talking about a box of sand. How many grains of sand? Grains of sand would you think would be in this box? It is approximately 330, and then again a butt load of zeros. Isn't this a huge number to work with every time? Now this is a quintillion. It has 18 zeros. This is 330 quintillion grains of sand in this one box. Okay, so how are we going to do math with this number over here or with this number over there? That's why the scientists thought of an easier way to work with numbers like this. Okay, so this number, we would count the amount of zeros. 1, 2, 3, 4, 5, 6. We say it's a 1. So we need to work it until there. So we count the decimal number, the decimal jumps. 1, 2, 3, 4, 5, 6, 7, 8. So 1.49 times 10 to the power of 8. And this one over here, this one has 18 zeros. 3, 6, 9, 12, 15, 18. But not just that, we have 2 more, so it's 220. So it's 3.3 times 10 to the power of 20. That is the number. Then it's easier to write. You don't have to write all those zeros all the time. Okay, so let's look at a few rules that we need to know. We need to know rules. Okay, we need to know that 100, let me use another pen. 100 equals to 10 to the power of 2. Why? Because it's 2 zeros. 1,000 equals to 10 to the power of 3. Why? Because there's 3 zeros. 10,000 equals to 10 to the power of 4. 100,000 equals to 10 to the power of 5. 1,000,000 equals to 10 to the power of 6. Okay, so those are the little bit of rules that we need to memorize. If we memorize these numbers, they will make our lives a little bit easier. Then we don't have to think about it. We already know the answer. Okay, so these are the ones that we need to know. We're going to use them quite often. Now let's look at the way that this is written. So standard form looks like, it looks like A times 10 to the power of n. Okay, where A is the number smaller. A is smaller than 10. Okay, and n is the number of times that you make the number smaller. So 10 less every time. So this is 8 less 10. So we divided this equation by 10 8 times. We divided this number by 10 8 times. That's why we got 10 to the power of 8. Okay, so let's look at an example. I know this looks and feels daunting, but the moment that you understand it, the better you'll be, because you'll understand it. The moment that you do an equation, you'll see how easy it is. Okay, so let's classify these numbers into two groups. Numbers in standard form and numbers not in standard form. Okay, our first equation is, or our first number says 4 to the power 4.2 times 10 to the power of 5. Is this a number in standard form? Let's look at our rules. We say it looks like A times 10 to the power of n. Yes, it does look the same, and A should be smaller than 10, and 4 is definitely smaller than 10. So yes, this is standard form. Let's look at another one. We have 3.678 times 10 to the power of 2. Does it look like the same? Yes, it does. Is it smaller than 10? Yes, it is. So yes, that is definitely standard form. Let's look at this one. 12 times 10 to the power of 3. Does it look like? Yes, it does. It has a number multiplied by 10 to the power of 3. Is the number smaller than 10? No, it is not. So this is not standard notation or standard form. Okay, then we have 463 times 10 to the power of 5. Does it look like this? Yes, it does. Is it smaller than 10? No, it's most definitely not smaller than 10, which means it's not standard form. Okay, so now let's write the following numbers in standard form. We have 7,000. How would we write that into standard form? Remember what we did here? We always start at the beginning of the number and we count. How many jumps do we do? 1, 2, 3. So it would be 7 to the power, or 7 times 10 to the power of 3. Our next number is 42100 000 000. Okay, so this is 42,100,000,000. Okay, how would we write that in standard form? We need to count our spaces, isn't it? We start at the back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then we have 4.21 times 10 to the power of 10. Now let's look at another kind of standard notation. We're going to go to negative numbers. So if we have 0.395 and we need to change this into standard notation, how would we do that? Again, we start at the point where the decimal point is. So then we count to the right. So 1. So we jumped one spot. Then we say 3.95 times 10 to the power of negative 1. Why negative? Because we jump to the right. Left, we go positive. Right, we go negative. Let's look at 0.003892. How do we write that into standard notation? Again, we start at our decimal point and we jump until we get a number that is smaller than 10. 1, 2, 3. So we jumped 3 times. So we then write the number 3.892 times 10. How many jumps did we do? 3. So negative 3. As easy as that. Okay, so standard form and scientific notation might seem daunting, but it is an easier way that we use to actually do mathematical equations. Please familiarize yourself with your calculator. Your calculator has this button that you can use as well. Okay, but again, before we run to the calculator, before we start using the calculator for mathematical equations, let's try to see if we can solve it with a pen and pencil and a page first. Because the reason why we're doing math is to give our brain some exercise. Okay, I hope you understand what standard form is, and I'll see you later.